So my talk is about extreme JavaScript performance. Extreme just sounds better, so it's really about JavaScript performance. I think I will take this out. Test. So in the program it says I will talk about profiling and other stuff. I've left out the profiling part because I think 30 minutes is a little bit too short for that. Instead, I will give you a bit of a general information about how you can make JavaScript faster, and I will show you that on some examples. So the first thing about performance, which is the most important part about performance, whether it's JavaScript or anything else, is do not ever optimize prematurely. Just only, it's really never optimize anything just because you think it will be a problem in the future. Just write your code so you can read it and it's manageable in the future, and only optimize when you actually do have a performance problem. And in that case, it will help you to profile your code and see what portions of your code that actually cause the problems, the performance problems. So the code I use in the examples of this talk, you can get that at this address, trim/extreme.js. It's a GitHub gist, so there's some code on there. Just throw that into an HTML file. You can look at that in your browser. So JavaScript performance is very interesting because it's not only you don't really have a defined environment your JavaScript runs in. I talk about JavaScript performance in the browser especially. It would also apply to server-side stuff, but let's see what browsers are up there and what JavaScript engines they have. So first there's SpiderMonkey, Firefox. It's pretty interesting. They have done a lot of stuff recently to make it faster. This JavaScript core in Safari and some other WebKit browsers. Also very decent JavaScript engine. There is JScript, which is like JavaScript without the other. Yeah, it works. We heard already that the IE guys are working on the next generation engine that will come out next century. And there's of course V8 in Chrome, and V8 is kind of an exception because Google really took the step ahead and made a JavaScript engine that runs separately for each browser tab and has a lot of other features that are very nice. Surprisingly, except for JScript, each of those engines is kind of fastest in some situations. So you cannot say one engine is faster than the other. You can do general, there's a general trend that JavaScript core and V8 are the fastest engines with SpiderMonkey trailing in close behind. And JScript is somewhere else. It's really interesting if you look at the examples. Anyway, so my first tip is avoid function calls. This is the beginner's tip. If you look at the code here, you see you have the square function that returns the squared, the parameter squared. And if you do 10,000 iterations, it has to do 10,000 function calls in there, except in JavaScript engines that inline the code. Or compared to that, if you do the statement correctly, directly in the code without the function call in the second example. So basically what we do here, we take the function call and inline it into the code. It's an obvious performance improvement because the function call just falls away. Function calls are very expensive in JavaScript normally. But this example would also apply to basically every other language out there. What are the results here? You can see Firefox this is like for, I don't know, 1 million iterations or something of this code. Obviously much faster to inline. Safari, also, the difference is not quite as high. On IE, there's like a little bit of a problem with the first method call. But you can see it's actually faster than Firefox. I'm not quite sure which version I used here, but it's like a recent version, so interesting. And Chrome like kind of beats the crap out of the other browsers. Actually, like with both methods of doing this. So you can see the differences in browser performance are quite huge. So for the IE part, what happens there? This happens. And interestingly, this warning comes up after 1 second of running, and I've got the same warning like sometimes after 5 seconds of JavaScript stuff that's running, and sometimes it comes up after 1 second. I'm not quite sure what happens there. Yeah, so be very careful with like tight loops that like calculate a lot of stuff. Okay, so we've seen earlier that there's now the web worker stuff in some browsers, which might help you avoid this kind of thing. But you can just optimize your loops, and maybe like you get under 1 second, and then you won't get those warnings. And these warnings, interestingly, behave differently in every browser. So your mileage really may vary with this. Anyway, secondly, embrace the language. What does that mean? Really use JavaScript the way it's like it offers all those facilities it has. Don't try to write JavaScript code that looks like Java code or that looks like C code or something. Write JavaScript. As an example of this, if you compare the performance of using literals for arrays or objects with doing new array or new object, which you see sometimes in bad code, you will see there's differences in performance. These things do not do exactly the same thing, but for all intents and purposes in normal code, they are exactly the same. How does this perform? You can see, slightly faster, Firefox. Safari is like much faster than Firefox here. IE, quite fast. Chrome is, interestingly, with like the new stuff, it's slower than Safari, but with the literals, it's faster than Safari, and overall, it's the fastest browser. You can see you can get some performance out of this. But you can do even more. Let's look at this example, parse int 12.5, okay, 12. That actually should be a string here. Sorry for that. But you can, in most languages, you can do things like in a lot of ways. There's, for example, there's Perl, where they say you can do everything in a lot of ways, probably in like infinitely many ways. It's probably not true in JavaScript, but you can do stuff differently. For parseInt, parseInt is kind of an expensive operation, mostly because there's a function call involved. So what you can do instead is this. This does do, for all intents and purposes, again, the same thing. What's going on here, you might ask. This is kind of like a bit tricky. So this is going on. You have a double bitwise not, which floors the number that it's given, and 1 times a string will coerce the string into a float, so it returns 12.5, and the double bitwise not floors the 12.5 to 12. Bitwise operations in JavaScript are interesting in this case because a bitwise iteration always forces the input for the operation into a 32-bit integer. So you can see sometimes you can use language stuff to kind of abuse it, but actually this stuff is faster than just using the parseInt. And in most cases, it's also shorter code. So you can see Firefox faster, Safari faster. Firefox is much faster here. It's like a lot faster. IE, yeah, and in Chrome actually parseInt is faster. So it seems they have optimized the parseInt call in their engine to probably not be a function call, but be something else, direct coercion into an integer. So it's really interesting. Firefox is 30 times faster than Safari for this operation. Loops. Loops is another like low-hanging performance fruit. Here's a for loop compared to a while loop. These two loops do exactly the same thing, except one counts up, the other counts down. The while I minus minus counts down the I until I hits 0, and then the expression is false, and then your code continues. So for each code snippet, it will add str 10,000 times to the test variable. How is the performance? It's easily explained. The performance is exactly the same. Which means, in this case, you probably should use the while loop, because the while loop is just shorter code, one expression less than the for loop. I personally find it easier to read. I don't like the for statement that much. It's kind of, I don't know, it feels weird if you can do something more elegantly. Your mileage may vary. Yeah. But what's much more interesting is this. So this is like a loop that counts down I 60 times and increases j for each iteration. Of course, this code is completely useless. But it's a nice example of what I mean. So here's the same thing. So guess what is faster? So the unrolled loop is like 2 times faster in Firefox. It's like 3 times faster in Safari. It's 2 times faster in IE. It's like 5 times faster on Chrome. The fun part of this is, this even works if there's like 2,000 expressions there. So the JavaScript parsers are very, very efficient in parsing JavaScript, but I guess they're not very efficient in doing loops. It's kind of an interesting finding. So I've actually did some JavaScript code in certain cases, to make it faster by unrolling loops and just having the same statements repeated over and over again. It's very ugly, but it really helps in some cases. Again, think about the first slide, that do not optimize prematurely. Fourth thing, cache globals. That's kind of interesting. If you have this code, if you compare it, the only thing we do is we cache window in a like local variable. This gives very interesting results. Like Firefox is really slow with this stuff. If you compare that, the speed, it's quite interesting. So in this case, Safari is 20 times faster than Firefox. It's also faster than Chrome is. In this case, IE works with stuff that's kind of, I don't know what's going on in IE. IE always like delivers the right results, but you're never quite sure about the performance. So what this stuff shows, that you cannot really say one browser is faster than the other, except that all browsers are faster than IE. And but actually found some cases where IE is faster than other browsers. IE is pretty good with some regular expressions. I think that the regular expression library on Windows is pretty optimized for certain things. So it might still not hold true that like all browsers are faster than IE. In most cases they are, but in some cases IE might even beat them. So it's more importantly, you really have to test your code on all these browsers. especially if you know that you have a performance issue in one browser, it's very likely that you have similar performance issues in other browsers. And also try your code on like hardware that's like not the latest and greatest stuff that you have for development, but that your users might have. Expression tuning, another low-hanging performance fruit in some cases. It's easily explained. You just like switch around the order of your expressions in the way you expect them to mostly be in most cases. In this case, b is false, so the n times n part of this expression will never get evaluated. You can see it helps quite a bit. On IE, it's like almost 3 times as fast. On the other browsers, it's also slightly faster. And it's important to note that this is a language feature. It's not like an engine optimization or anything. The like second part of this expression will never get evaluated at all. So in this code, you see, I'll define n to be 1, and I say if true and n equals 2, which means the second part of this expression will only be evaluated if the first part is true, and this is true in this case, so n will be set to 2. But in the second part, I say true or n equals 3. So true is already true, of course. And so the second part of the or expression will not get evaluated, and n will not get set to 3. You can use that in some clever ways also to optimize the size of your code, and also to make sure that no one ever will understand your code again. But in certain cases, it might be the right thing to do if you really want to optimize the last bit of performance out of your code. And finally, we have stuff that you should never ever do. Let's look at the with statement. The with statement is kind of cool. It allows you to write shorter code, but. So this code again does the same thing. Let's look at this. Firefox, it's like 5 times faster. Safari, slightly faster. IE, the same speed, interesting. On Chrome, it's like more than 10 times as fast without the with. It shows an interesting thing, which we'll come to in a second. But let's look at another thing that you should avoid. Trycatch. Trycatch should probably only be used in cases where you want to test for browser features, where you know that like certain code might throw an exception, or like in very rare cases where performance is not important, but you really don't know if an expression will succeed or not, and you don't have any facility to check your input before you do your expressions. So what happens here? So with the try-catch, you can see in Firefox it's almost the same. So in Firefox it's not really a problem. In Safari, oh well. On IE, same thing. Chrome, again, 10 times as fast. It's more interesting to look at this like this. So you can see Firefox, Safari, IE, Chrome. What happens there? Why it is like the same speed for both expressions, for both forms, with try-catch, without try-catch on IE, but not in the other browsers? The answer to this is relatively simple. In the browsers where the difference is, these are the modern JavaScript engines that have just-in-time compilers and like do a lot of optimization on your code, translate it to native code in most cases. But certain features are not supported by them very well. Among them, try-catch and the with statement. A good way to like think about this in a way of like how can I avoid that these modern engines have to switch to the like slower code paths because I use features that they might not support as well for just-in-time compilation, is looking at the specification for the next version of JavaScript. It's ECMA 262, 5th edition draft, whatever. Of course, no one ever reads these specifications because you have other stuff to do, like make a living and stuff. You don't want to read this stuff. You want to leave this to other people mostly. There's a very good blog post John Resig wrote about the features in there, especially about the strict mode features. And the strict mode is very interesting. So here's a link to John's blog post. Basically, avoid any stuff that's not supported in the strict mode, and you will stand a good chance that the code you write will be very efficient in those new JavaScript engines. The strict mode, for example, does away with the with statement. It still has Trycatch, so it only works partially, but if you do write code that would work with JavaScript's new strict mode, you'll stand a good chance that your code will be very, very optimized. So does anyone know what this code does? No? Come on. It's a JavaScript conference. So, okay. Okay, so this code outputs itself. It's just a little example I whipped up because I wanted to show you an interesting, so to say, feature of JavaScript. JavaScript is very well suited to metaprogramming, and one feature of metaprogramming is introspection, and one feature of introspection is you can actually get at the source code of your code from within your code. So in JavaScript, if you write a JavaScript function that says arguments.callee.toString, the function will output itself. You will get a string that contains the function. And with a little bit of trickery here, we normalize this output because this output is a little bit different across engines, and we can alert the function itself. So, but what does it mean? So here's another function. So you can see I define a function, it returns 2 times 3. I want to get at the source code for this function. So let's have a look what the engines do. So JavaScript core gives you back function, return 2 times 3. Internet Explorer gives you back function, return 2 times 3. Chrome gives you back function, return 2 times 3. So what does Firefox do? Gives back return 6. So I think this is WTF. So there in Firefox, actually, there is another function called toSource, which is not in the specification, but which gives you back what you originally put into the function. This is an important thing to say because the problem with this is that if you write benchmarks, browsers might try to optimize your functions for you, and especially for benchmarking, this is pretty bad because you want to know exactly what an expression does. So be wary that JavaScript engines might rewrite your code actually. And yeah, just note that these engines are all a little bit different. So Amy and me wrote a book on JavaScript performance. You can get it at jsrocks.com. So much for the advertisement. Again, do not optimize prematurely. Never, ever. Thank you. So, any questions? I can barely see here. These things are very... Yes? So the question was, how were the measurements done? obviously the measurements were done in JavaScript itself. In JavaScript, you can measure like a time period by using new date get time. You get like the Unix timestamp in milliseconds, and yeah, like you do it before and after the test. What I do is I do like a really long loop that iterates, like executes these functions like a lot, and mostly in like 100,000 times, a million times. If you look at the sample code, the benchmark function is included there. As we describe in the book, we actually also use like a different benchmark function that also does like a ramp up and ramp down. So it does basically the like 1 million executions 3 times, but only measures the second execution. So things like garbage collection and stuff in JavaScript are kind of you can like work around that a little bit, but it's still not like scientific. But if you execute it like 10 times, then the whole thing, you get a pretty good idea about how fast the browser is. The problem with these comparisons, as you have seen, sometimes they get you get very small numbers. But because I need to like compare IE to Chrome and stuff, I cannot use bigger numbers because I don't know, I want to go to bed at the end of the day. And I'm sorry if I'm bashing IE too much, but this is like the hard facts of JavaScript performance. Any other questions? The question was if I like have like a software tool that like basically optimizes code for me. Is that right? No, I don't. I just use the like oldest programmer tools like Brain and Hands, mostly eyes, I guess. But there is, as I said before, we probably don't have enough time to like cover like profiling tools. But the thing is, it's actually, I think, more difficult to determine which parts of your code actually like cause the performance issues. And then you can go in and like try different things. Like some of the things I've shown you today, unrolling loops, trying to optimize the order of the expressions. It's different for every problem anyway. I guess you could write some code tools that like just try certain optimizations and compare them. And know that like the new Google Closure stuff has like some of this stuff built in when you put your JavaScript into their compiler. It optimizes certain things. I don't know if it's exactly these things. It's too new for that, but yeah. So it's one tool that's available for this would be like the Google Closure compiler. Actually, I've tried it with some new code I'm writing called Emil.js, which is like this mini JavaScript animation library, and it broke the library. So go figure. By the way, tomorrow at 12:15, I think, I will do a talk in the underground track. No? Okay. I was told I was doing the talk. Okay, so maybe tomorrow I will do a talk about Emil.js, so you're welcome to that. Like, I've applied some of those things you've seen today to that code. Thank you.